know what we need to work on. I'm ready.
So it was, I have 3 questions. One was from 4.2, and it was f of x equals the square root of x minus 1/9 x, not under the radical.
Good.
For the domain 0 to 81.
Yes.
And we had to use.
So it's like this. The function is like this. Okay, good. Good. So the domain for this function is x.
0 to 81.
Yes. And are we asked to find the absolute max min?
No, it was use Rolle's.
Rolle's theorem. Okay.
Yeah.
To find the C guaranteed by Rolle's theorem. Awesome. In number 1, we have to say that f is continuous on the interval 0, 81. How do I know? This is linear, which is continuous everywhere. This is radical the square root of x, and this is always continuous on its domain from 0 to infinity. Number 2, f is differentiable on open interval 0, 81. That's true, because when I differentiate this, I get 1 over 2 the square root of x, and it will not be differentiable at 0. It's undefined at 0. And this is differentiable everywhere. And this is differentiable on 0 open to infinity. So this is done. Now in step number 3, in order to apply Rolle's theorem, step number 3 has to be f of 0 is and f of 81 is. If these two numbers are not the same, I will check the answer. Rolle's theorem is not applicable. If these two are the same, then I will proceed. Now I have to see. When I plug in 0, I have 0 minus 0. When I plug in 81, I have 9 minus 9 over 9, which is 1. So 9 minus 81 over 9. So 9 minus 9 is 0. So all 3 conditions are fulfilled. Therefore, Rolle's theorem, double L, Rolle's theorem guarantees C in the open interval 0, 81 such that f prime of C is 0. So what I need to do is, of course, first, sorry, I had to mute you. Sorry, my apologies. So first, I have to find f prime. So then f prime of x is 1 over 2 the square root of x minus 1 over 9. Do we all agree with f prime? If we agree with f prime, then we'll move on. If we don't agree with f prime, then we have to talk about it. Is this okay? Is f prime okay?
Yes.
Okay, perfect. So now I have to plug in C in it. Okay, no problem. 1 over 2 the square root of C minus 1 over 9. Rolle says that it's 0. I will move 1 over 9 to the other side. Maybe this is not the best color, sorry. So 1 over 2 the square root of C equals 1 over 9. And remember what we do in a proportion. I can swap both sides or cross multiply. But just remember that this is a minor or a little trick. So 2 the square root of C equals 9. I have to divide by 2. And I have to square to get C. So C equals 81 over 4. Does this belong to 0 to 81? Of course. It's 20.25. Any questions on this problem? Amanda, is this okay? Any questions?
No, I realized what I was doing. Instead of squaring at the end, I was finding the square root for some reason. So.
Yeah, no. So if there is a square root over c and we have to find c, then we have to square. We have to always use the inverse operation.
Right.
Good. Other questions? Anyone else? Okay, I put it aside. Page 2. Yes?
4.4.
Yes, I'm ready.
Okay, so for 4.4 it is the limit as x approaches 0 for tangent of 5x divided by sine of 8x.
Perfect. So the first thing I have to do is I have to plug in. I love it. There is no issue. So then I have limit as x approaches 0. When I differentiate tangent, I get secant squared 5x times the inner function prime. When I differentiate sine, I get cosine 8x times the inner function prime. It happens that these are 1. This approaches 1. This approaches 1 when x approaches 0. So therefore, the answer must be 5/8. Any questions on this one? Any questions, anyone? Anyone, please?
I figured out. I did the inner function prime for the numerator, but forgot the inner function prime on the denominator. So
yep, that's always remember, you have to say always times the inner function prime, times the inner function prime. And you will never forget. Well done. Next question.
So my last one was the limit as x approaches infinity. X approaches infinity for natural log 3x divided by the square root of 3x.
Awesome. Great job. Good. So when we look at natural log, we always have to remember this function, please. So this is natural log, or 3x of x, it doesn't matter. When x approaches infinity, this approaches infinity. So the numerator goes to infinity. The square of infinity is infinity. I love it. I don't have to do anything. Just apply L'Hopital's rule. So this limit as x approaches infinity. When I differentiate natural log, I have 1/3x times 3, the inner function prime. When I differentiate the square root of 3x, I have 1/2 the square root of 3x times the inner function prime. Is this okay so far?
Yes.
Perfect. So now I have a fraction at the top and a fraction at the denominator. So I will have limit as x approaches infinity. I copy the fraction from the top, but I have to flip the fraction from the denominator. Good. So now look at what happens. Yeah, I have that too. Fine. Beautiful. I'm going to put it in front. It's a constant. It's a factor. But I have the square root of 3x divided by 3x. So I have 3x to power 1/2 over 3x to power 1. It's the same base. So 2, limit as x approaches infinity, copy the base and subtract the exponents. 1/2 minus 1, that is negative 1/2. So negative 1/2 will really mean to limit as x approaches infinity 1 over the square root of 3x, because it's negative, 1 over with positive. But now I know that tiny divided by infinity will be what? Times 2, it will not make any difference. 1 divided by huge. I have $1 and I want to share it with everyone on the planet. When I knock to your door, how much will I give you from that $1? Exactly. Every time we calculate a limit as x approaches infinity or negative infinity, we have to write, and we get a number. Y equals 0 horizontal asymptote at infinity. How come that I don't consider it at both? This is not a rational function. And at negative infinity, I won't be able to plug it in. As x approaches negative infinity, this doesn't even exist. So careful. If it's a pure rational function, yes, I will consider both sides. But if it's not a pure rational function, I have to be careful. Very good. Any questions?
Can you go back to where you have the limit as x approaches infinity of 1 over 3x times, yes, I got that, but then to go from there.
So 2 goes in front because it's a factor. And I have 3x to 1/2. The square root means 3x to 1/2.
Okay.
Divided by 3x to power 1. Then I copy the base and I subtract the exponents. 1/2 minus 1 is negative 1/2. From the power of the numerator, I subtract the power of the denominator. And that's how I get the negative 1/2. Is that okay?
Mm-hmm.
Then it's negative power. It goes to the denominator. 1 over 3x to 1/2. But that means the square root of 3x. And then when we plug in infinity, 1 over huge approaches 0. Is that better?
Yes, thank you.
Perfect. Okay, I have a little discussion for you, so I'll stop and